Alright folks, welcome back to my channel. In the last video, we looked at a couple of ways we could filter our data so we can see just live matches. And this means we'll be getting a lot of data to get fresh data, so we also looked at ways in which we can refresh our page so that we keep having the scores that are the most up to date. Now, the problem is with all of this, we need to hit the API multiple times. We have multiple API calls going back and forth. Now, imagine if sports announcers and commentators had to describe every game live without ever referring to past plays. It would be exhausting. That's what our app does without caching. Today, we'll add SQLite, which is like a stat notebook, to remember match data efficiently, and also add Redis, which is like instant replay systems on a jumbotron. Now, why do we need this? Naturally, when you're building web apps or any apps, you get to struggle with slow loading times, hitting API rate limits because of the multiple calls, and it generally gets frustrating to your users. So, what we need to tackle is this huge performance bottleneck, which is the excessive API calls. So, we're going to explore techniques, maybe 2 or 3 different techniques that will be able to help us. For instance, SQLite for lightweight local storage, or Redis for lightning fast in-memory caching. These will significantly reduce those pesky API calls and supercharge our Flask app performance. So how do we do this? We need to fetch that data once, we store it, and save it directly from our own application for subsequent requests. That's exactly what caching and local storage allow us to do. Our first option, perfect for small scale applications where data doesn't change super frequently, is SQLite. It's fantastic serverless database that's incredibly easy to integrate. And guess what? With Python, it actually comes built in with SQLite. So let's dive into our app.py file, our Python file. And for a basic Flask app, first we need to import SQLite. That will be SQLite version 3. We also need datetime library for managing our cache. Now we have an init database function that creates a match, or should I say creates a matches table if it does not exist. This table will store our API response data and the timestamp for when it was last updated. Now, the magic actually happens in our fetch matches function. But before we hit the external API, we want to check our SQLite database if we find cached data that is less than, say, 5 minutes old. We just return that directly and we don't need to get any API call anymore. Now, only if the cache is stale or empty do we make that external API request. Once we get fresh data, we update our SQLite cache with the new data and the current timestamp. So, with SQLite, we're reducing API calls by storing data locally. It auto-refreshes at an interval that we get to define, and it's best for all because it's persistent, meaning that our cache data survives even if the server has to restart. So, at the end of the day, SQLite is an excellent starting point. It offers us with this solid performance boost without any complex setup. But what if we need even more speed? What if our app demands real-time updates and lightning-fast responses? That's where Redis comes in. Redis is an incredibly fast in-memory data structure store. It is perfect for high-performance caching. So like I said earlier, when we talked about SQLite being like a physical storage, the notebook that is being used by maybe a coach, Redis would be like the stadium's jumbotron screen. It stores data in memory for lightning fast access, but it forgets everything once it's powered off. So it's perfect for temporary caching. Now, to use Redis, we will first need to install Redis Python library using pip. You've seen this in multiple of our previous videos how we use pip. And of course, we also need to have a Redis server running. Once that's set up, connecting the Redis in our Flask app is super simple. We just import Redis and connect it to our Redis instance. Now, remember, you need that server to be running, the Redis server. You might go to redis.io/download to get one from there. And make sure you choose the right operating system. You might have challenges setting it up for Windows or Linux or Mac operating system. So drop me a comment if you'd like me to go in detail on how to get this Redis server set up. Now, back to our app.py. The Redis library is imported, similar to how we did with SQLite for our fetch matches. We go into the function for Redis, first attempt to retrieve data from the cache. So instead of querying a database, we just use Redis's get method to check for a key. If we find cache data, we return it instantly. If not, we make the API call, and here is where the key difference is. We use r.setX, which is set expiration date or time, to cache that data. So setX allows us to set an expiration time, in this case 300 seconds or 5 minutes, after which Redis will automatically remove that data for us. Now, Redis is blazing fast because it stores data in memory. It automatically handles the expiration of all data with its time to live or TTL feature. And it's incredibly scalable, making it highly ideal for high traffic production ready applications. So you've now gotten SQLite and Redis in action for caching API responses. But how do they compare? Let's break it down. The key differences that will help you choose the right tool for your project. SQLite stores data on the disk, making it persistent even after the server restarts. But it's also a bit slow due to the disk input-output. Alright? Redis, on the other hand, is in memory, which makes it incredibly fast. But by default, it's not persistent unless you configure snapshots. Going back to SQLite, it's great for small projects and local development. But Redis is going to shine in production environments with high traffic. So, which should you choose? Use SQLite if you want zero setup, no extra server is needed, and your data doesn't change that often. But use Redis if you need millisecond response times and you're deploying to production. To summarize, start with SQLite if you want zero setup and your data doesn't change very often. Optionally, you should go with Redis if you need millisecond response times and you're deploying to a production environment. But wait, there is a bonus. For maximum resilience and for best option for both worlds, you can combine both SQLite and Redis. How is that? Now, remember, like this video, comment below, and I'll be telling you in a split second. Now, in this combined approach, we first try to fetch data from Redis. If Redis is not available or doesn't have that data, then we fall back to SQLite. Only if both caches fail do we then hit the external API. And when we get fresh data from the API, we update both the Redis cache and the SQLite database. This gives you the speed of Redis with the persistence of SQLite as a reliable fallback. This combined strategy is excellent for mission-critical applications where data availability and performance are paramount. So, my final recommendation: start with SQLite for simplicity, especially during development. When your application starts growing and traffic increases, switch to Redis for that performance boost. And for those truly critical applications, embrace the power of both for ultimate resilience. Now, by implementing these caching strategies, you will not only significantly reduce your API calls, but also drastically improve your Flask application's performance and user experience. Now, if you found this video helpful, please give it a thumbs up, subscribe for more programming tutorials, and let me know in your comments below which caching strategy you prefer for your Flask apps. Thanks for watching. This is V2'sDK. You already know, because I'll be seeing you in the next video where we're going to revamp our application and add some bells and whistles to make it shine.